The entrance to a port, low tide is measured at 6 meters depth, and at high tide the depth is 12 meters. On a particular day, the low tide is at 0500 and the first high tide at 1100. Model the depth d of the water at the port using a function of the form given here. Well, let's have a bit of a sketch of this. So we've got low tide first, so low tide here and then high tide here, and so presumably that's going to do something like that, and then there must be another low tide over here and another high tide up there, like so. So we know that that one happens at 5, this one happens at 11, that's 6 hours in between. So what we're saying is that another 6 hours on, that one must be happening at 1700, and then this one must be happening at 2300, like so. Okay, so, well, first of all, 6 and 12, so we know that this is 12 up here, and that's 6, so in the middle of those is 9, so straight away d is equal to 9. This one goes downwards to begin with, so I think we'll take a is equal to -3. Well, we could take it as +3 and it will just adjust the value of c. So there's different answers that will give you the correct thing. Now the period of this function is 12. So what we must have when t is 12. So we've got 12b must be equal to 2 pi, which gives us that b is equal to pi by 6. Okay, so let's look at what we've got so far. So we've got d is equal to -3 sine pi by 6t plus c plus 9. So what do we know? We know that sine of 5 pi by 6 plus c, that's when it's at the bottom here, so that must be equal to 1 because of the -3 there. And so 5 pi by 6 plus c must be equal to, so when that would be 1, that would be at pi by 2, which is 3 pi by 6. So c is going to be -2 pi by 6, which is -pi by 3. So what we've actually got is -3 sine pi by 6t minus pi by 3 plus 9. So that is our modelled function. You could actually find values here and here such that this one is 3, and you could find a value there as well. So there's more than one way of doing it. Okay, so for this next bit, OP's tanker can only safely enter the port when the water depth is 10 meters or greater. Between what times can he enter the port in the afternoon? So 10 is going to be sort of here. So what we want to do is find all these intersection points. And so he can't enter between those two times there. So in the afternoon, so the afternoon starts at 12. So we'll have to see what happens when we graph it. So the way to do this one is to go to graph and table and clear out everything we've got. So of course we do need to be in radians here. So what have we got? We've got -3 sine pi by 6 hex, take away pi by 3, and then add 9 to that. And the other thing we're interested in is 10. So we'll put that there, like so. So we need to graph this anyway. So let's just graph them. They won't appear at the moment because of the window I've got. So I'm going to go from 0 to 24. And on the Y, let's go from 0 to 13, say. Should give us a good picture. There we go. And so we want these intersections, and these are the morning ones, and those are the afternoon ones. So it's only the afternoon ones we want. So now let's just G-solve intersection. So I'm going to want that one there, which is 13.35. And next one over, which is 20.65. Now I'm also going to just state the equation I'm solving. Remember, I've got 3 marks here, so I've got to not just write answers down. And then I'll just say CAS gives me that. Now, from what we can see on the graph, it's from 12 up until this time. So we're going to say 1200. So now remember, this is not 13:35 minutes. So what we're going to have to do is work out 0.35 times 60. So it's 21. So that is going to be 1321 hours. And then same thing over here, 0.65. Multiply that by 60. That's 39. So that's going to be at 2039 all the way up to 2400. Which is 0.000, isn't it? Well, let's leave it there. I'm sure we'll get the marks.